Hi, Pete. I'm Eric Pike. I'm the VP of Business Development here at ScaleFlex. Excited to be part of the team working on and leading the journey towards delivering new compute and storage solutions combined, solving real challenges that our customers are facing.
So in a prior webinar, we discussed ways that SSDs fail your applications and how ScaleFlex solutions provide you with a way to avoid those pitfalls. Well, today, we're going to be focusing on one specific aspect, and that's latency. We'll start with sharing various ways you can spend your time while you wait. In addition to discussing those 7 things, we'll also cover why latency is bad, why it happens, how it can be addressed, and some next steps. So, a fundamental principle in the business universe is time is money. In the world of technology, we use the term latency, which is simply the time it takes to complete a task. Latency matters to everyone. If you don't optimize for it, you have to find something else to do with your time. So we've come up with several examples.
Well, one of the things you can do is load a different mobile app. Sometimes you go to load something and it just takes too long, so cancel that one and go load the next one because it's not responding.
Been there, done that. Or while you're waiting for that to happen, you can call your mom back. I'm sure she would appreciate it.
Another one that we all experience is you get in Monday morning, you load up your virtual desktop, and it's just really slow. So go get yourself a cup of coffee. It's a better use of your time.
Yeah, I've been there, and we're going to talk about that specific example later on. Or while you're waiting, you could merrily hum a song.
That's true. Here's one that you really don't want to do, but reschedule your meeting. Postpone it to another date because you just don't have the data you need. It took too long to get your database to run.
Right. Or, even better, stare blankly at a wall like the one behind us here, because you're contemplating why you don't have the data and what else you can do at this point.
I guess in the end, go find a new job. Search for new job listings because you just can't get your job done. It's taking too long.
Well, yeah, true that, right? All of these are ways to fill time, but clearly they are not ways to improve your business or any business for that matter. In fact, many of these hurt productivity and your business. So there has to be a better way. And today we're going to help you understand how picking the right storage device can help you get that costly time back. So on the screen you see storage units or garages, and we're going to build an analogy on why storage latency exists. So you can think of an SSD as a group of storage units or garages, and writing data is similar to putting boxes and other items into that storage unit. Well, once you fill a storage unit, like the picture on the right there, you move on to the next one. And at some point, you may decide that you no longer need that old desk or some boxes that are buried in the middle of that storage unit. To get to them, you'll need to pull everything out. Well, instead, you just make a mental note that you're going to have to get to that some point at some day, right? Then one Saturday, when you have the time, you decide to go in and clean out everything that's in front of it that are not worth keeping to get to that stuff and to free up space. Because if you don't do that, you'll never have space for any new items when the time comes for you to add more items.
Yeah, that's right. That's very much the way NAND works inside of an SSD. You fill storage units, in this case it's NAND devices. And that cleanup that we're referring to in the industry we refer to as garbage collection. And so it's that process of going in and removing data that you've tagged for deleting. While garbage collection is actually happening, one of the problems is that you can't read or write to the data in that particular location until you finish that process. You have to go in, pull out, do the garbage collection, get rid of the stuff you don't want, and put everything back in its place, and now it's accessible for reads. So as long as you have extra free space when you're putting in new stuff, this problem really doesn't matter because the garbage collection is happening in the background. But once you fill up the device and everything is completely full, now you're stuck in a situation where you actually have to wait for garbage collection to happen to create space so that you can write new data and put new things inside. And this is when you start experiencing latency delays. This is when your application starts slowing down and you start facing some of the frustrations we were talking about earlier in terms of, hey, I can't get stuff done, and you're waiting for data.
So I'm assuming that the more an application writes data, the more you'll be waiting for that to read the data, right?
That's exactly right. That's when those collisions happen.
Yeah, so in my storage unit analogy, my wife and I recently purchased a box of home supplies that needed to be dropped off at the storage unit. Well, I couldn't fit it because the storage unit was full. But I knew that there was things in the storage unit that I no longer needed. So I had to take the time to move items out, to get to those items, to rearrange it, to fit that new box. And what my wife thought was going to be a simple and quick task took much longer than expected while she sat in the car waiting, not happy about waiting for me to do this. It was supposed to be super simple.
Yeah, time is definitely valuable. In this particular case, the relationship of time and your relationship with your wife was a bit of a collision. Having the right storage solution and having the right architecture there really does make a big difference. So let's take a little bit of a look at what this particular scenario looks like at an SSD level. So, here's a graph. Oh, wait a minute. Not quite sure.
Yeah, you're not retiring anytime. You're not retiring anytime soon, by the way.
Well, ironically, this graph happens to be. This is how I had a mistake there. It's the same data, but this particular one talks about what happens at an SSD level now. So, as we were talking about, initially you have plenty of space. So you see that performance at the beginning of this chart looks really good. And what this chart is showing here is the performance measured in IOPS, or IOs per second, over the time, starting with an empty drive. So at the beginning of this, we have an empty drive. And so for that first hour, things are screaming along. You don't have any of those garbage collection problems we were talking about. It's kind of like putting stuff in your storage unit. You have plenty of space, no big deal. You hit that 1 hour mark, just before the 1 hour mark, and all of a sudden, we fall off what we refer to as the write cliff, which is I'm trying to write more data, and there's no free space on the drive. So that garbage collection has to start creating space. And while that garbage collection is creating space, it's holding back on new data coming in, and you see exactly what's shown in this particular graph, which is the write cliff. Now, one of the things about SSDs as well is today, the common practice is you precondition an SSD. And this chart is exactly why we precondition SSDs.
And that's for synthetic benchmarks and testing?
That's exactly right.
Okay.
You want to get to the point where that's steady state. What you don't want to do is suddenly in the middle of your test have the performance go off a cliff. So what we do today is the standard practice is to fill up an SSD for many hours so that now I'm at that stable state.
Got it. Got it.
Now, taking that sort of performance we just described at a raw device level and translating it into an application, here's a particular test that's representative of a row-oriented database called Aerospike. Here again, we're going to focus on a couple of conventional NVMe SSDs in the market. In this particular test from Aerospike, what they do is they pump transactions through this database, and they see how many transactions they pump through the database before the access to the database, or in this case, the read latency, gets too slow. And for this particular test, for this particular type of workload and for this environment, they use 1 millisecond as that threshold for the test. And given the fact that anything has outliers, they give a tolerance of 5%. So basically, a test passed as long as less than 5% of the reads are greater than a millisecond.
Got it.
So what you can see here on the left-hand side of this chart is with about 240,000 transactions, both drives passed just fine.
Those are those dark gray lines on the bottom.
Exactly.
Got it.
Right? And then when you get to about 300,000 transactions, so now they're pushing more transactions into the same device, one of the drives gets a little bit worse. The other one actually disappeared off the chart.
Okay.
And the test actually aborted because they were exceeding the read latency significantly. So it actually just failed out of the test. Push that all the way up to 360,000, and now both of these drives you're pushing too much work through, and it's just too long for them to respond.
And that's where it starts failing the test.
That is correct.
Got it. Well, so having more space on the drive would likely have prevented these collisions, resulting in better overall performance. Now, people have historically solved this challenge in multiple different ways to help make sure there's enough space for new drives, for new writes.
Yeah, this is not a new problem. We're not talking about some new physics or some new technology from the point of view of how an SSD works. They still function the same way. So what people do is in some environments, they'll add more systems. They'll add more SSDs. They'll just physically add more space. But often that's not an option. You either have filled up all the drives in your system, or you just don't have any more rack space, or you don't want to buy another rack or buy another system. So it's just not an option. The alternative at the device level is kind of reserve space. Reserve space is basically setting aside space that doesn't get used for user data. So you hold back on that space. So you ensure you have free space. We call that over-provisioning. And over-provisioning is setting aside that user space.
Got it. Well, I've seen customers do this, actually. They take a 7.68 terabyte drive and are forced to over-provision it to 6.4 or even 3.2 terabytes to make sure that they get enough performance out of the drive. That means they're paying for all of that space and are only get to use a fraction of it. So in the storage unit example, it's like filling each storage unit only halfway, right? That's not efficient.
Precisely.
And paying for extra units, potentially. That's what the picture is demonstrating there. And if I had that extra unit, then my wife wouldn't have been sitting waiting in the car because I would have been able to drop it off and go, right?
Yep,
But
exactly.
that's, these solutions are expensive and inefficient, right? That's not everyone can just keep adding more drives. It wastes time, space, and money. So shrinking the stuff we're putting into our storage unit, if I had a magic shrink ray, would be a more efficient solution to create this free space that we need to prevent the garbage collection collisions,
Yep,
right?
exactly, Pete.
So that's what this picture's trying to show here.
Yeah, this is a dream world. But
Yeah.
we actually bring that into reality in our technologies with scale flux. So what we do is we compress the data. We have transparent inline compression, which reduces the data, reduces the footprint of the data. It's the same amount of data. We're not talking about like, eliminating data, putting something. Same data that's coming in, we reduce the size of that data through our transparent inline compression. That additional space then improves the performance, eliminates those collisions we've been talking about, and therefore results in a better experience for the users.
So we have the shrink ray.
We do.
That's
we
awesome.
do. So now, taking that prior data that we were looking at before and comparing it here, we've got, the right cliff. Sorry, let me just. Oops. All right. Well, we'll show the right cliff. Yeah. So showing that same data that we had before, you see that same right cliff that we were talking about, which was the red line we showed earlier. What you now see with the scale flux drive in here is, we don't show the right cliff. The right cliff has basically disappeared. And, that's again, simply because of that same phenomenon we were talking about, is we've created that shrink ray. We've reduced that amount of space, which means we always have free space. Both of these drives have the same amount of data being written to them, right? The user data being pushed into them
And they're both
exactly
the same size drives, too.
That's precisely.
Right.
That's precisely right.
Right, so no more cliff diving.
That's right.
Okay.
That's gone.
All right, well, that's impressive, but folks that are watching, and you and I know that synthetic tests and benchmarks don't always translate into real-world results. So let's share some real-world data.
Yeah, so moving away from the synthetic test into the real-world data. Again, same data we looked at before.
Yep.
That same Aerospike test with the 1 millisecond, 5% threshold. What you see now is we've added the scale flux drive.
And that's at the bottom, circled in green, the little purple area
That's
on
the
the
purple
slide.
area on these slides. And so again, at 240,000 transactions, all 3 drives pass. There's a little bit of a significant difference with the scale flux drive. But again, all 3 drives are passing the threshold. You get to that 300,000, you even get out to 360,000, and you barely see a marginal difference in the scale flux drive. Still pumping right along.
Yep.
In fact, we took this test out over 500,000 transactions, and it still continued to pass. We had to get well beyond that in order to actually see failures.
Yeah, in our prior presentation, we said hashtag it's not fair. Well, that's just simply not fair.
That's right.
So bringing this back to one of the real-world productivity examples we gave in our top 7 list there was the Monday morning virtual desktop login, where everyone comes in on Monday into the office and logs in, and you wait for your environment to come up, resulting in delays because everyone's doing it at the same time, establishing their virtual environments. So this is something that I've experienced, and I'm sure everyone who's worked in that kind of environment has seen. So compressing the data should also help in this situation, I would expect.
Very good. Yep. So let's take a look. This is actually third-party data. So this wasn't even generated by ourselves. This is generated through a third-party company called Storage Review. And what you have on this particular graph is, again, that latency, that waiting time. And in this case, they use IOPS on the horizontal axis for throughput, which would basically think of it as how many virtual desktops are you trying to load at once, right? And so when they ran the testing without and with compression. And again, the results speak for themselves in terms of when compression is not available, you have limits in terms of what you can have and things start slowing down. Turn on compression. Not only can you do more desktops, but more desktops happen faster. Again, it's unfair, I know.
Yeah, but that's
what this technology is about.
It's also very, very important to highlight that there are no application changes required to achieve these benefits. There's nothing to be done here.
That's right. We use the word transparent to mean transparent, meaning as a user, you're not making any changes to the software stack or to the OS or having to do anything else in that space. Zero application or system changes. It's the easy button. You just plug it in and it creates these results.
Yeah, you're correct. It's one easy step. Absolutely. So what does one of these better solutions looks like? Well, it adds compute engines to an enterprise NVMe SSD. The compute engine is accomplishing all of those benefits for us, and it's a simple swap and replace that provides the transparent inline compression, the higher performance, and the insanely less latency that we've been showing in our graphs and real-world results. As you can see from the list of features, it also provides additional capabilities that we will be covering in separate upcoming webinars. And today, ScaleFlex drives are available in U.2 and half-height, half-length add-in cards, which is a mouthful to say. And with raw capacities up to 16 terabytes in raw, which at 4x compression, or you can definitely improve latency.
That's right.
But you may be thinking, I could use host-based compression. I've done that before to solve for this kind of issue, to achieve similar results. And we're going to be also demonstrating in an upcoming webinar specifically the advantages of drive-level compression as opposed to doing it in a host as an offload to allow your host to do more capabilities. But don't take our word for it. We encourage you to see how easy this is by submitting your request for 2 free drives and trying this in your own environment. So we'll review those requests and we'll follow up. And my team are also available to discuss specific workloads, applications, and use cases and answer any questions. But the easiest way is really just to try it yourself. And I believe we may now have some time for some attendee questions.
Yeah, so we got a question that came in that says, can you actually store more capacity per drive? And the short answer to that is yes, right? We focused today in this particular webinar on the performance aspects, which is use all of that compression to create that performance. But certainly the option is, the alternative is to dial up the amount of capacity that you're using. So the cool thing about our technology is we actually give you that dial. We give you that knob that you could choose to use more performance in your applications or turn it the other way and use more of that space to store more data.
And depending on the compressibility, it could be both.
Yes.
You can get beyond 2x. We were showing 2x. But you can get 3 or 4x compressibility that'll achieve both lower latency and higher performance, and more capacity.
That's right. That's right.
So you showed pre-conditioning on ScaleFlex drives. Performance do you have to do that?
So that question was, you talked about the preconditioning on the one chart earlier, but then you didn't show it on the second chart. This chart that was a little bit awkward. Yeah, the short answer is we still use preconditioning on all of our drives as part of our standard testing. But with new technologies, we see many times in this, it kind of changes some paradigms, right? You now look at it and you go, do I really need to spend an extra 7 or 8 hours testing? And while we haven't yet decided that that's going to be a new standard, the question is valid in terms of we've changed the technology, changed the paradigm, and you may not need to do that preconditioning anymore. Or at least certainly not to the extent that you've done it previously. That's one of the exciting things about being on the front edge of new technology.
I think that chart showed we get to a steady state and a consistent steady state sooner.
Yeah, which is always a good thing.
Absolutely.
So question was, how do I follow up and get drives? I think you're the best person for that one.
Well, there is we did have on the screen and may still have on the screen a place to go to sign up and request those drives. It's at scaleflex.com/landing/POC. But we're also you could reach out to any of us directly, and we're happy to point you in the direction and answer any questions that you may have. We're here to help you succeed, right? There's no risk, and You can see how easy this is yourself.
Yeah, absolutely. So if there's any other questions available, we'll take them through. Otherwise,
Yeah, and if it's not now, if you're more comfortable reaching out and private messaging us via LinkedIn or any other method, you can find us on LinkedIn, and we're happy to quickly follow up and take your questions after this. Well, thank you very much, and we look forward to working with you and enabling your success and driving business forward.
thanks, Pete, for letting me join you today. Hopefully the next person
Eric.
here has as much fun as I did.
Awesome.
Thank you.
Thank you.